Hi everyone, this is the individual assignment for CS 4501 Software Engineering. Today I'll be talking about unit testing. So the outline of this talk is going to be, first I'll talk about what software testing is. We'll look into some cases where software testing is important. We'll talk about software testing as part of the larger software development process, and then we'll look into some levels of software testing. Then we'll talk about unit testing, which is a specific level of software testing as a whole. And then we'll first talk about what it is. We'll talk about unit testing, and then we'll talk about the advantages and disadvantages of unit testing. So we'll look at cases, where you should use unit testing for your software development process, and some cases where you shouldn't use it. Then we'll talk about the types of unit testing. So we'll get into details of this, and then we'll talk about unit testing tools. So the two tools that we'll be looking into are JUnit and Mockito, and then we'll conclude at the end. So without further ado, let's get into software testing. So to talk about software testing, we need to start off with the software development lifecycle. So this is a process that includes planning, analysis, design, implementation, testing, which is what we'll be focusing on for the rest of this, and including this slide, and maintenance. So the goal of the software development lifecycle is to create high quality software that meets customer expectations while minimizing project risks. So in the course so far, we have discussed planning, analysis, and design of the software. Today, we'll focus on testing. So software testing is an important process in the software development lifecycle. It involves verifying and validating that a software application is free of bugs, meets the technical requirements set by the design and development, and satisfies user requirements efficiently and effectively. So let's talk about why software testing is important in the software development lifecycle. So some things that we can do with software testing is it can help us save money for the project because defects can be identified earlier on in the development process instead of releasing the software and then solving it later. So software testing is an important tool because if there are any bugs, they can be identified early and can be fixed before the delivery of the software. It also improves the quality of the software. So by doing software testing, we uncover the defects in the software and fix the problem um, and provide a higher quality software in general. It also increases the customer satisfaction. So by doing software testing, we ensure reliability, security, and high performance, which results in saving time, costs, and customer, and leads to a better customer satisfaction. So software testing also enables us to save time and money in the software development process. So after the application is launched, it will be very difficult to trace and resolve the issues of software development. So it's better to do it earlier on in software development. As performance, this activity will incur more costs and time. Thus, it is better to conduct software testing at regular intervals during software development. So this picture shows some things you can achieve with this software testing. So you can save money on your project. It can lead to higher security for the project. You can deliver a higher quality product using software testing. It will lead to ultimately it will lead to a higher satisfaction for the end user, for the consumer of the software. It can enhance the development technique, so incorporating it as part of the software development process, especially earlier on in the process, can enable like a higher quality product. So it's easy even as adding new capabilities, and it can increase the performance of your software. So now let's talk about the levels of software testing. So software testing can be majorly classified into four levels. So this talk is going to be focused on unit testing, but there are other levels of software testing that are integration testing, system testing, and acceptance testing. So let's look into what these levels are. So unit testing at this level of the software testing process, we look at individual units or components of the software system and test those units. And the purpose here is to validate that each unit of this software performs as designed. For integration testing, this is a level of the software testing process where individual components are combined and tested as a group. So the purpose of this level of testing is to expose faults in the interaction between integrated units. So this is the second level of testing. The third te level of testing is the system testing. At this level of the software testing process, where a complete integrated system or software is tested, the purpose of this test is to evaluate the system's compliance with the system requirements. And finally, the last level of software testing is the acceptance testing. It is a level of the software testing process where a system is tested for acceptability. The purpose of this test is to evaluate the system's compliance with the business requirements and assesses whether it is acceptable for delivery. So this picture here shows like the different levels of testing. So it's essentially different levels for each system. So you're doing unit testing. Another level of software testing is integration testing and system testing and acceptance testing. So unit tests essentially test the individual component of the software. Integration testing tests the integrated components of the software. System testing tests the entire system as a whole, and acceptance testing tests the final system. So now that we've talked about software testing as a general process in the software development cycle, let's talk about the specific level of software testing, which is called the unit testing, which is going to be the topic of this talk. So unit testing is the process of testing the smallest parts of your code, like individual functions or methods, to make sure that they work correctly. It's a key part of software development that improves code quality by testing each unit in isolation. So unlike the other testing methods, unit testing allows us to look at individual components of the software development. So we consider each function and each a method and test it in isolation. So unit test is a small piece of code that checks if a specific function or method is an application, um, it works correctly. So we want to see that each component of the whole system is working correctly. So we split it into these units for individual functions and methods, and then we test each individual method. So it will work as a function inputs and verifying the outputs. These tests check that the code works as expected based on the logic the developer intended. So by splitting the entire project into these test cases and then running each individual unit test, we can iteratively run this process and do a test of the whole software. So now let's talk about some advantages and disadvantages of this method. So we're here talking about unit testing. So what are the advantages of unit testing? So the advantages of unit testing include early detection of issues. it can lead to a higher so what that means, the early detection of issues is unit tests allows developers to detect and fix issues early in the development process before they become larger and more difficult to fix. So fixing the issue early on in the process can lead to early detection of issues. So it can also provide an improved code quality. So what that does is unit testing helps to ensure that each unit of code works as intended and meets the requirements, improving the overall quality of the software. So as a combination of of these two, you can see that by adopting early detection in our software development, we can improve the quality of our code. It can also increase the confidence. So, unit testing provides developers with confidence in their code as they can validate that each unit of the software's function is unexpected. So, by using unit testing, the developers can gain a higher confidence in their code. It can also lead to faster development. So, unit testing enables developers to work faster and more efficiently. And they can also validate the changes to the code without having to wait for the full system to be tested. Unit testing can also lead to better documentation. So, unit testing provides clear and concise documentation of the code and its behavior, making it easier for other developers to understand and maintain the software. Finally, it can also lead to reduced time and costs. So unit testing can reduce the time and costs required for testing later, as it helps to identify and fix issues early in the software development process. So again, to reiterate, there are many advantages of unit testing. Um, if we incorporate unit testing early on in the process, we can detect issues earlier. We can improve the quality of our code. It gives developers more confidence in their code because they know each individual unit or method or function is working the way they want, which can lead to faster development, better documentation, and then reduce time and costs by doing these steps. Now let's talk about some disadvantages of unit testing. So as we can see that it's a very involved process to do these unit tests because you're splitting your entire software into individual units. So this obviously leads to more time and effort required. So unit testing requires a significant investment of time and effort to create and maintain the test cases. And especially if your system is more complex, breaking it into these units can require a lot of time and effort. The second aspect of unit testing is the dependence on developers. So the success of unit testing depends on the developers who must write clear, concise, and comprehensive test cases to validate the code. So this leads to, an over dependence on developers to make sure that they're splitting the entire software into these units and then testing each unit. Which, if it's, and we'll talk more about the different types of unit testing. So, if it's a manual testing, this will especially be more dependent on developers and which will require more time and effort. So, another disadvantage of unit testing is that it can lead to difficulty in testing complex units. So, unit testing can be challenging when dealing with complex units, as it can be difficult to isolate and test individual units of the isolation from the rest of the system. So, when the project becomes more complex, there are two aspects to this. One is it becomes harder to break the process into chunks or these units. And then the second case is once you break a task into these units, testing an individual component can be difficult as well. If it's a complex system. And especially if that subsystem depends on other components or other methods or functions. So especially when different functions are working together, it's hard to test them individually. Another issue with unit testing is an over-reliance on automation. So over-reliance on automated unit testing can lead to false sense of security, and automated tests may not uncover all possible issues or bugs. So even though we're creating these units and then we're testing them, um, it can lead to us believing that we have covered all possible issues with the system. And even though individual units work, if your software, the system as a whole might still not work the way you want. So even though individual units are passing your system requirements, the overall system might not. Another issue and another disadvantage with unit testing can be maintenance overhead. So as you can see, there are more time and effort that's involved and dependence on developers. This can add to the costs as well as uh, it requires an ongoing maintenance and updates to the code and the test cases. So so because of these reasons, unit testing can't be implemented for every software project. Now let's talk about some types of unit testing. So unit testing can be broadly broken into two components. And actually, so before talking about the different types. Let's consider some factors that can make unit testing less essential or less beneficial for the customer. So I'll go back to this slide. So of course, if there are time constraints in your project, writing unit tests can take a lot of time, and even with an automated tool, which we'll talk about in the next slide, it can still lead to time constraints and you might miss deadlines to deliver the product and can lead to a higher budget for the project. And then testing old or legacy code can be very challenging with this unit testing. If the existing code is not written well, then it may be hard to test without referencing writing, which can also be time consuming. And finally, in projects where requirements are frequently changing, it may not be practical to write tests for all codes, as the code may change before the tests are even run. So for these reasons, unit testing can't be applied for all projects at all software levels. But knowing that there are two types of unit testing, manual unit testing and automated unit testing, if there were ways of coming up with more efficient automated testing software, and we'll talk more about the two software that we're looking into, which are JUnit and Mockito. So let's talk about the types of unit testing now. The first type is manual unit testing. So manual testing is like checking each part of the project by hand without using any special tools. So people like developers can do each step of this by themselves. So the problem with doing a manual unit testing is that it costs more because workers have to be paid for the time that they spend testing, especially if it's not a permanent staff. So to do these unit tests, you need to hire workers, you need to hire developers, and you need them to break the task into these units. It takes a lot of time because the tests have to be done every time the code changes. It is hard to find and fix problems because it is tricky to test each part separately. So, and finally, like developers often do manual testing themselves to see if the code works correctly. So, hiring a separate developer for creating these unit tasks may not be the most efficient way to do t testing for the whole software. So with manual unit testing, there are obviously some problems involving the fact that it costs more to hire more developers to do these unit tests, and it can lead to the project not having uh, not working as efficiently. So the other type of unit testing is the automated unit testing. So automated unit testing is a way of checking if software works correctly without needing lots of human effort. So this is where unit testing becomes an important tool for the software developing lifecycle, and so it requires special tools that are run to test things automatically. So the way this works is developers write a small piece of code to test a function in the software. This code is like a little experiment to see if everything works as it should. So just because it's an automated process doesn't mean there is no human effort involved. There's a minor human effort involved. But you're still not testing it manually. You're writing a code that tests the software um, uh, in an automated fashion. So before the software is finished and sent out to the user, these test codes are taken out. They're only there to make sure that everything is working properly during the development. And automated tests can help us check each part of the software on its own. This helps us find out if one part is dependent too much on the other. It's like putting each piece of the puzzle under a magnifying glass and to see if everything fits the right way. We usually use special tools or frameworks to do these testing automatically. These tools can tell us if our code does not pass the test we set up. The tests we write should be really small and focus on one specific thing at a time. They should also run on computer's memory and should not rely heavily on the internet. So automated unit tests is like having a helper that checks out our work and builds software, making sure everything is in the right place and works as expected. So this kind of relates to the previous point of so unit testing not being the most efficient solution because it requires more effort to do this. But if we had a more automated way of doing these unit testing, then we can provide a better solution, and it can minimize these disadvantages of unit testing. So now let's look at some examples of automated unit testing tools. So the two tools that we're going to be looking right now are JUnit and Mockito. So JUnit is a widely used testing framework for Java applications, which helps create and run repeatable automated tests. It's best for writing and executing test cases with strong support for test lifecycles and assertions. So an example of a JUnit is given below. So this was taken from the JUnit's website. So the way this framework works is it's an automated tool for doing the unit testing, and it's best for writing and executing test cases with strong support for life cycles and assertions. Now let's look at Mockito. So Mockito is a mocking framework that lets you write tests in clean and simple API. Providing readable tests and producing clean verification errors. It is ideal for isolating components by mocking dependencies and verifying the interactions. And then here is another example of the implementation of Mockito. So you can this code is in Java, so you can import this Mockito library, and then using these commands, you can write the unit tests for in an automated fashion. So to conclude this talk on unit testing is a fundamental practice for ensuring software quality that validates the individual units of software in a proper manner, checking if the function works correctly and meets the requirements of the project. While it may offer benefits such as early issue detection and improved quality of code, it requires a significant time and effort on the developer's part. Checking the challenges such as difficulty in testing units and UI elements. UI testing is crucial for ensuring software quality and longevity of the software. Tools like JUnit and Mockito provide robust framework for writing and running tests. Now, to conclude all of this, I'd say, we use unit testing as part of, which is a level of the software development testing to test individual components of the software. So the important idea here is that just because you're breaking the task into these units and testing them individually, you also need to see if they work together. And this is where tools like JUnit and Mockito can help, make sure that these units work as a whole as well. And finally, unit testing is not just a process, it's a discipline that fosters confidence in your code. So it's incorporating it as part of the software development process, not just leaving it for the software testers, can help the developers have more confidence in their code because they would know each component of the software is working correctly while they're building the software. And this is an important way of knowing that your software, and this can ultimately lead to more customer satisfaction, a better and higher quality of product that you will build, and it can ultimately, even though implementing unit testing can be expensive in the beginning, but the drawback of not having good testing in place is that it can lead to more overall costs at the end. So unit testing is a great way to make sure you save on overall time and money as well by incorporating this as part of the software development process. So some at the end there are some references that are used for creating this talk. So I used these two links from Geek for Geeks about unit testing and software testing, and then I also took the code from the JUnit and Mockito website. All right, thank you so much.